All right, guys, going to be going over homework 5 here. Be careful. We're going a little bit out of order, skipping 4 for now, just so we can go ahead and finish the different number sets, decimals, fractions, all that. I just don't like the way the order that the homework goes in, so we'll be skipping that. For now, we'll be coming back to homework 4 later. Homework 5 is fractions. Two-part lecture. We'll be doing more fractions next week, or in homework 6. So we can call this intro to fractions, and we also will be covering multiplication and division. Luckily, they're actually easier with fractions than with them with decimals, certainly, so hopefully not too big a deal there. What is a fraction? Generally speaking, I think most of you guys know this already. It's a rational number, right? Didn't we talk about this before in the first lecture? A rational number. Just to remind you about the phrase where A is the numerator. Remember, we used P and Q then, but same thing. A is the numerator, B is the denominator. You probably already knew that. Fractions can come in several forms. There's normal fractions where the top is smaller than the bottom, the numerator is smaller than the denominator. Fractions can be negative on top. They can be negative on the bottom. None of that really changes anything. They're still fractions. You can have mixed numbers, right, where you have a whole number and then a fraction. And you can have what's called improper fractions where the top, the numerator, is larger than the bottom, the denominator. Improper is sort of a poor choice of words here, in my opinion. It implies that there's something wrong with it. There's not anything wrong with it. So we'll put normal under these, even though that's not, we don't really use the term normal fraction. This one here is a mixed number. And this one here is an improper fraction. But again, improper really meaning top heavy, not so much a problem. So if, like, you know, I'm jumping the gun a little bit here or getting ahead of myself, but if one of your answers in your homework was 19/7, as long as the answer says it'll take improper fractions, there's nothing wrong with that answer. So just right off the bat, we'll talk more about mixed numbers and improper fractions in the next unit, but just right off the bat, they are legitimate fractions, regardless of kind of what the name would imply there. A couple other small things about fractions, just some intro information. Any number, A being any number, right? You can put anything you want in there, 5, 7, negative a million. Any number can be written as a fraction by putting it over 1. Remember, that doesn't make it rational. A rational number has to be composed of integers within the fraction. Just remember that. And one other thing that I like to remind people about, because this is something people will oftentimes goof up, and we'll just squeeze it in up here. There is a difference between having 0 in the bottom of a fraction versus having 0 in the top of a fraction. These are not the same thing, and there's a strong possibility you're going to be tested on this idea because this is something kind of fundamental. The first one says this is a number divided by 0, because remember, fractions are division. The second one says we have a 0 divided by a number. 0 divided by a number is just 0, right? How many times does 3 go into 0? Well, it goes in 0 times. A number divided by 0 is not, I don't want to say it's not clear. That's not exactly correct terminology. It just simply can't happen. If we were maybe in a regular lecture, I'd go over this kind of idea with you. It's a little outside the bounds of the class, though, and I'm trying to keep these lectures just to the critical information, just so you know you guys aren't watching hours and hours of video. But just for now, you know, if you're interested in the whys, you can always send me an email. But bottom line is, if you divide by 0, it is undefined, meaning not allowed. It simply cannot happen. You can divide into 0, and you will get 0. So make sure you know the difference on those. That is something that's quite possibly going to show up on an exam. Couple things I'll mention before we get into the actual mechanics of the fractions. There's some questions in the homework, and I actually think these are pretty good questions. This is something a lot of people have trouble with. It'll ask you to kind of show where a fraction would go on a number line. So let's talk about these for just a moment, just because these can confuse people, and I also think they're valuable questions. Let's say it gave us 3/10, and it said, where on a number line would this go? Or a ruler. Sometimes they'll do it on a ruler. Let's draw a very crude number line here. Let's say we had 0 there, and we had 1 here, and just for balance, we'll say -1 there, right? So 3/10, that's less than 1, right? If you have 3/10 of an item, you have 3 parts out of the 10 that make a whole item. It doesn't mean there's 10 in the world, but it just means every 10 parts will make a whole item, and you have 3 of them. So what you're going to notice here on the homework is this thing will be broken up into tenths. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and then 10/10, which is 1, right? So we're talking about 3/10, so it'd be 1/10, 2/10, 3/10. It would be right there. okay? So it's just simply, the number just has to be broken up into tenths, and then you're just looking at 3 of them. If they gave you an improper fraction, let's say I said 27, well, that's gonna take forever to graph. Let's say I said 13/4 just for to make this a little smaller. Again, here would be our number line. Now, 13/4, think about that. That's going to be bigger than 1, right? Because you have 13 pieces and every 4 of them make a whole. I mean, we're sort of getting into mixed numbers here, but I mean, just generally speaking, if you have 13 pieces, how many times does 4 go into 13 evenly? Well, 3 times, right? So this number is going to be 3 and some change. So over here, we'd have maybe 1, 2, 3, and 4, okay? And if, it could start at 0. It just depends on the number line. There's no guarantee where they're going to start you at. But you probably want to realize that 1 is 4/4, right? 4 out of 4 is 1. It would be 5/4, 6/4, 7/4, 8/4, right? That would give us 2, because 8 divided by 4 is 2. This is sort of the way you want to think about it. 9/4, 10/4, 11/4, 12/4, because 12 over 4 is 3, and 13/4. So it would be right there, just past 3. Does that make some sense? Okay. So that's how you kind of show where a fraction is on a number line. You simply just count out how many of these you have. And in the homework, the number line will be divided up for you into fourths or tenths or whatever it is you need. All right. So just wanted to touch on that quickly before moving into the mechanics of the fractions. So the thing that really kind of slows people down with fractions, honestly, is the reduction. So fractions have to be reduced. So let me give you an example. This is something that will be in place at all times. You should go ahead and just make this sort of a, you always stop at a stop sign kind of thing, one of those internal commands that you just know. When you are doing fractions, you must reduce the answer. The answer must be in simplest terms at all times. What do I mean by that? Well, if I told you 3/6, right, you said, what was my score on the test? And I said 3/6. Wouldn't you kind of come back to me and say, don't you mean 1/2, right? Because 1/2 is a simpler way to say it. 3 out of 6 is a half. Well, 1 out of 2 is a half, and that's the simplest way possible to say it, right? Because, I mean, you could get into silly stuff. You could say, oh, I got 54 out of 108. Well, I mean, that's still half, but it's just so much simpler to say 1/2. So we're always going to be looking for the most reduced form of the fraction. Check your homework carefully. If it marks the question wrong, the reason is because it may not be reduced. It might say something like although your answer is correct, it is not in the correct format, meaning it's probably not reduced. So this is something you're going to have to look out for on almost every problem. It may not occur on every problem, but you're going to have to watch out for it. So let's start off with an example here. Let's say I gave you 8 out of 12. And that might be the answer you got from, a bunch of other work, or maybe it's where they started and they asked you to reduce it. Give us the reduction. Simplify it. What you're doing here is you're looking at the numbers and you're saying, what goes into 8 and 12? What can I reduce the numerator and the denominator by? Hopefully you see, pretty straightforward. This one's going to be 2. This is just my notation, y'all. I put a little R2 just to say I'm reducing by 2. You're really dividing by 2. I just don't like writing division signs everywhere. So 8 divided by 2 is 4. Remember what you do to the top, you got to do to the bottom. 12 divided by 2 is 6. 4 over 6 is a reduced version of 8 over 12, but it's not reduced all the way because, again, I can do a 2 again, right? I could reduce by 2 again. 4 divided by 2 is 2. 6 divided by 2 is 3. And now we have 2/3. That's reduced because nothing other than 1 will go into 2 and 3, 2/3. So that's the final answer there. Just to make the point, though, there's multiple ways to get there. Let's say you said 8 out of 12, and you had said, well, 4 goes into both, right? We used 2 last time, but what if I did 4? Well, 8 divided by 4 is 2, and 12 divided by 4 is 3, and you end up with 2/3 straight away. So you might say, well, the second one was faster, and it is faster, but it's the same thing ultimately. Here you reduced or divided by 4 to the top and the bottom. Here you reduced by 2, and then 2. And what's 2 and 2? It's 4. So you're reducing by the same values either way. The bigger the number, the less steps you'll have to take. So you oftentimes will want to kind of shoot for the bigger number, but it doesn't matter. If all you can do is kind of chop it down by 2s and 3s, there's nothing wrong with that. All right. Well, if we did a little bit of a bigger one, let's say I said -36 over 28. All right. Remember, you are reducing the same fraction, so the answer will still be negative. If it starts negative, it's going to end negative. So kind of look at that and ask yourself, what goes into 36 and 28, right? Well, 2 does. 2 goes into both. They're both even. Does 3 go into both? People have an issue with 3s, and I'll kind of teach you a quick trick. This is a trick. This does not work with other numbers. So don't get too excited, but it does work with threes. Add the numbers up. What's 2 plus 8? It's 10, right? Does 3 go into 10? No. Then 3 does not go into 28. So again, add the numbers up, 2 and 8. That makes 10. Does 3 go into 10? No. Then 3 does not go into 28. 3 does go into 36. 3 plus 6 is 9. And 3 goes into 9. But it's got to go into both, so 3's out. We got 4. 4 goes into 36. Yep, 4 goes into 28. And I don't really know of anything else that goes into both of those. That doesn't mean there isn't something, but the bigger the better, but it doesn't require you get the biggest number every time immediately. So let's reduce by 4 and see where we're at. 4 goes into 36 9 times. Don't forget your negative. 4 goes into 28 7 times. And then just take a look at what you have. Negative 9 over 7. Nothing goes into 9 and 7. And that means that we got the biggest. We got it right away, right? Immediately we reduced it and got the correct answer, which means we reduced by the biggest number possible. If you have to reduce by multiple steps, it just means you kind of broke it down into smaller numbers. But ultimately, it's the same thing, guys. So don't get too hung up on this. A couple more examples, because the numbers aren't always sweet, like 8 and 12 and things like that. We'll do maybe a couple, 3 more examples. Step it up a little bit here, make the numbers a little bit uglier. What if we said 90 over 115? And again, this may be how the problem starts. We might start that problem off and just say, just reduce that, please. Or that might be the answer you got from multiplying some fractions together, and now you have to reduce it just to finish the problem. Either way, reduction is required. Looking at 90 and 115, the numbers are a little bit bigger this time, right? Like, I don't know what goes into 115 and 90 other than what? 5. So start with 5. It's fine. 5 goes into 90. Well, 5 goes into 100 20 times, right? And this is 2 5s less than 100, so it's 2 5s less than 20, so 18. You can always divide it out longhand if you want. Similar, 5 goes into 120 times. 15 is 3 more 5, so 23 times. And again, if you're not comfortable doing it in your head, then don't. Write it out. Do it out with long division. It's not a problem. So you have 18 over 23. Does anything go into 18 and 23? I don't think so. 18, 2 can go into it. 3 can go into it. 9 can go into it. But 23 doesn't have any divisors other than 1, so I think we got it. So just because the numbers are big doesn't mean it's going to take forever. Let's do one more regular one, kind of an ugly one this time. Because they're not all real sweet. They're not all real nice, and some people sometimes will have problems with these. So try this one out for a minute. Take a minute on your own, negative 117 over 273. Start small, 2, 3, 4, 5, and go from there. See what you can do. Of course, I'll work it out, but I would encourage you to go ahead and hit the pause button and see what you can get. All right, so clearly they're not even. So that means if I'm checking numbers, 2 is out. If they're not even, 2 doesn't go into them. Does 3 go into them? Well, remember the trick we just checked with 3s. Add the numbers up. 1 and 1 is 2, plus 7 is 9. 3 does go into 9, so that's looking good. 2 plus 7 is 9, plus 3 is 12. 3 does go into 12, so 3 will work. Can we use a bigger number? Probably. There probably is a bigger number that goes into these, but I don't know what it is. And probably you don't either. And there may not be. That's the thing. There is no guarantee. There probably is because these numbers are bigger, but let's just go with 3s. Now, how do we know how many times 3 goes into that number? Well, like I said a minute ago, you might have to just do some long division. 3 goes into 1 0 times, so we can skip over the 11. 3 goes into 11 3 times. 3 times 3 is 9. Subtract, bring down. 3 goes into 27 9 times. So that gives me 39. Let's go and push this over here. That gives me 39 on top. Negative. Don't lose your negative. And since we divided by 3 up top, we're going to divide by 3 on the bottom. So I wanted to do this problem just to show you guys that you will have to do it a little bit of longhand division sometimes unless you're just very strong with mental division. 3 goes into 2 0 times, so we can skip over. 3 goes into 27 9 times. 9 times 3 is 27. Subtract and bring down. And 3 goes into 3 once. So that's 91. So we have negative 39 over 91. So take a minute, make sure that makes sense to you. And then you have to ask yourself, are you done? Because just because 39 and 91 look done doesn't mean they are. They may be, but they may not be. So let's go through the list here. Are they even? No. So 2 doesn't go in. Does 3 go in? Well, 3 goes into 39, right? Because 3 plus 9 is 12, but 9 plus 1 is 10. 3 does not go into 10, so 3 does not go in, so 3 is out. Now here's the nice thing. Because you tried 2 already, you know 2 didn't work, so neither will 4. Don't bother. No other even number is going to work because 2 didn't work. What about 5? Well, 5 doesn't go into 39 or 91. What about 6? Don't bother. It's even. You already tried 2. What about 7? Well, this is where knowing your times tables will help, right? 7 does not go into 39. The closest you can get is 35, so that's out. 8's out because we already said no even number is going to work here. 9 is out because I already tried 3, and 3 makes up 9, right? 10 is out because no even number will work. 11 is out because, well, a times table. 11 times 3 is 33, and that's not 33. 12 is out because no even number will work. 13, I don't know. So really the only thing left to do is just try 13 into 39. So let's go ahead and just bring this down here because I'm running out of room up there. Now, you might already know, you might have seen this the whole time and been screaming, well, 13 goes into 39, and it does. So let's reduce by 13 on top, and that gives us -3. I'm sort of cheating a little bit because I actually know 13 is going to go into 91 as well. How many times does 13 go into 91? Well, if you try it with long division, you're going to kind of dead end here. 13 goes into 9 0 times, 13 goes into 91. How many times? Same question we just asked, right? So at a certain point, you will just have to try some things, multiply it out a little bit. 13 times 10 is too big, right? 13 times 10 is too big because that makes 130. Let's try 13 times 8. Again, this is just my illustration that these are not always going to be simple problems. We started here, got it here, and now we're trying to work on breaking it down with 13. 8 times 3 is 24, carry the 2. 8 times 1 is 8, plus 2 is 104. It's too big. Let's try 13 times 7. 7 times 3 is 21, carry the 2. 7 times 1 is 7, plus 2, 91, and there it is. So 13 goes into 91 7 times. So there's an example of one that's not so sweet. We started out at -117 over 273, went to -39 over 91, and then divided by 13 to make -3 over 7. And that's an example of, you know, kind of how ugly it can be. They're not all going to be that ugly, and they're not all going to be sweet, and most of them will be somewhere in the middle. So make sure that makes some sense to you. I did want to say one more thing about reduction before we kind of close that off. There are some problems in the homework that'll sort of ask you to reduce backwards. I don't want you to get confused by them. So just real quick, you might see something like this. It'll say 12 over, I don't know, 26 or something like that equals blank over 13. And then there'll be a question mark here or something like that. It'll ask you what the missing value was. What they're basically doing is saying, hey, look, we took this fraction here and we reduced it to make this fraction here. What did the reduction turn out to be? Well, whatever they did to make 26 into 13 is what they did to make 12 into whatever it turns out to be. So really what you just need to do here is figure out how they got from 26 to 13. And hopefully you see that they divided by 2 or reduced by 2. Well, if I did 26 divided by 2 to make 13, wouldn't I say 12 divided by 2 to make 6? So the missing number would be 6, right? So all they're asking you to do is kind of just do the reduction yourself and tell them what the missing number is. So don't get hung out to dry there. Nothing crazy. Actually, just going to get another sheet of paper. I hate wasting paper like that, but we're going to move on to a new topic here. So that's reduction of fractions. The thing about reduction is, again, it is something you're going to have to watch for on most problems. It's not going to be there every time, but if you don't catch it, it will be. You know what I mean? Like the one time you don't look for it, that's when there's going to be reduction. If you're not careful, your answer will be wrong. So let's talk about how to multiply fractions. I'm going to go ahead and just write out the full definition here. It's kind of ugly. Most of y'all aren't going to like this, but just to get it out of the way. If you have two fractions, A over B, where A and B can be whatever numbers you want them to be, it doesn't matter. And then you have times C over D. So again, A, B, C, and D are just whatever numbers you want. The way you multiply fractions, it's real sweet. They're straight across. A times C over B times D. So in a nutshell, multiplying fractions is about as simple as it's going to get. And again, simple doesn't mean easy. Simple just means there's not a lot of steps. Multiplying fractions straight across. Doesn't mean that, you know, the numbers are going to be small, and it doesn't mean that you won't have to reduce, but there's not a lot of steps here. Use multiply straight across, and then of course reduce if possible. So at its most basic, let's say I said I had -3 over 7, kind of goof that up there. Negative 3 over 7 times 4 over 5. Well, like I said, just multiply straight across. Negative 3 times 4, that's negative 12. 7 times 5, that's 35. And the only thing you need to do now is just check for reduction. Does anything go into 12 and 35? Well, what goes into 12? 2, which does not go into 35. 3, which is not going to 35. 4, which is not going to 35. And 6, which does not go into 35. So in that case, we're clear. Is there a way to tell if it'll reduce beforehand, though? Because you don't want to sit there looking at every problem. You know, you multiply the tops together, you multiply the bottoms together, and then you got to sit here trying to work this number down. That is the way it goes, but yes, there is a way to tell if it'll reduce in the problem. In this case, it would not, and maybe we'll come back in a minute. You can tell how I knew that. So let's take a look at another example here. But again, remember, the bottom line is how to multiply fractions. You multiply straight across. Let's say I said negative 2 over 7. I'm writing this stuff way too small. Let's try that again. Let's say I said negative 2 over 7 times negative 21 over 4. Try to make this a little bit bigger for y'all. Now, if I wanted to do this straight up, we could. Negative times negative is positive, and 2 times 21 is 42. 7 times 4 is 28. And that's, you know, and that's what happens. You multiply them across, and that's what you get. Now, we'd have to sit here and look at this and say, well, what goes into both? Maybe we could reduce by 2, right? 2 goes into 41 21 times. Excuse me, 2 goes into 42 21 times. 2 goes into 28 14 times. Then we have to look at our answer and say, well, can I reduce it again? And maybe so, yeah, right? Because 21 and 14 can both be reduced by 7. 7 goes into 21 3 times. And 7 goes into 14 twice. So if you do it straight up and multiply straight across, there is a little bit of reduction. We had to reduce by 2 to get 21 over 14, and then reduce by 7 to get 3 over 2, okay? There is a way to tell if that's going to happen in the problem. Let's take the same problem and kind of work it over down here. Let's say I said, well, it'd be the same problem. So negative 2 over 7 times negative 21 over 4. Here's the thing. 21 and 4 cannot reduce, and 2 and 7 cannot reduce. But there's something called cross-canceling or cross-reduction that happens, and this is for multiplication only, so let me put a little star here. You can do what's called cross-canceling. It's not required. I just did the problem without it, right? I just did the whole problem without it. I multiplied straight across, and then I just reduced the numbers at the end. But if you look at this, and you can say, well, I can't reduce up and down, but the question is, can you reduce any numerator with any denominator? And the answer is yeah. 2 and 4 can reduce, right? Doesn't 2 go into both of those? 21 and 7, doesn't 7 go into both of these? So we can cross-cancel both of these number sets. Here's how this would look. You would say, it's still reduction, so I'm going to reduce by 2, except I'm not going to be doing it up and down. I'm going to be doing it on the diagonal. This is only allowed for multiplying. Be very careful about this. Don't do this when you're adding, subtracting, or dividing. 2 goes into 2 once, and then we're going to do it on the cross here rather than up and down. 2 goes into 4 twice. I reduced 2 by 2 and got 1. I reduced 4 by 2 and got 2. So now instead of a 2 and a 4, I have a 1 and a 2. I've reduced inside the problem. You might also notice that 7 and 21 can work, so we can reduce by 7. 7 goes into 7 once, and 7 goes into 21 3 times. You probably would want to rewrite these now. So what you have is negative 1 over 1 times negative 3 over 2. Negative 1 times 3 is 3, and 1 times 2 is 2, and you got the same answer we did just a minute ago. So whether you like to cross cancel or whether you like to just multiply straight across and reduce at the end, you will get the same answer either way. So we'll do a couple of examples, but I just really want y'all to understand it does not matter how you choose to reduce. That's going to be the real hang up, honestly. The multiplying is not hard. I mean, think about what we did in this problem. I just multiplied straight across. It's not the multiplication that's going to hang you up. It's the reduction. Reducing 42 and 28 to get 3 over 2. So if you're not comfortable reducing big numbers, get comfortable with the cross canceling. So let's take a look at another example. We'll do it both ways again. We'll do it out just by multiplying straight across, and then we'll do it out with cross canceling just to kind of illustrate the difference. But luckily, that really is it for fraction multiplication. You multiply straight across, and that's about it. So let's say I gave you 2 over 56 times 40. First things first, you got to recall back to the beginning of the lecture. What this really means is 2 over 56 times 40 over 1. Didn't we say that earlier? Any fraction can be made, or any number can be made into a fraction by putting it over 1. So if I just go through this the brute force way, 2 times 40 is 80. 56 times 1 is 56. And now that's my answer, 80 over 56. The question is now, can it be reduced? And of course it can. Of course it can. They're both even, so they can both be reduced. So let's go ahead and reduce by, well, what? What do you think? Take a minute and think about it. What's the biggest number you can come up with? 2 for sure, right? And that might be it. So if you're not comfortable, then just go with 2s. I think you could probably get away with 4 here as well, but we'll do 2s. 2 goes into 80 40 times. 2 goes into 56 28 times, all right? Then you say, well, 40 and 28 are both even again, so I'm going to reduce by 2, maybe one more time. 2 goes into 40 20 times. 2 goes into 28 14 times. And this is the problem with reducing at the end, is it sort of can just go on and on and on. And we're going to finish it up here very shortly when we reduce maybe by 2 again. 2 goes into 20 10 times. 2 goes into 14 7 times. So ultimately, we came out with 10 over 7 as our final answer there. But I had to reduce by 2, and then 2, and then 2. I had to do it 3 times. So what number could I have used to reduce this all at once? Well, what's 2 times 2 times 2? 8, right? 2 times 2 is 4, times 2 is 8. So if we started with 8 right off the bat, 8 goes into 8 10 times, 8 goes into 56 7 times, we would have had it done in one shot. So a lot of this depends on your skill with division. If you're not skilled with division, you can always just hammer it with 2s and 3s and 5s and things like that, all right? Now, what if we wanted to do this with cross-canceling? So I had 2 over 56 times 40 over 1. And I didn't want to just multiply it all, and I wanted to do a little reduction in the problem itself. Well, same thing, right? You look at 40 and 56, or 2 and 56. We'll do 2 and 56, and you can reduce by 2. 2 goes into 2 once. 2 goes into 56 28 times. So what we have now is 1 over 28 times 40 over 1. And then you say, well, 40 and 28, I can reduce those by 2. Remember, we can reduce on the cross. 2 goes into 40 20 times. 2 goes into 28 14 times. This might be sort of looking familiar the way we did it last time. Put that back together. You have 1 over 14 times 20 over 1. And how often you need to rewrite it like I'm doing is up to you. And you say, well, I can reduce by 2 again. 2 goes into 20 10 times. 2 goes into 14 7 times. And you end up with 10 over 7. Was either way quicker? Not really. Was either way easier? Not really. You reduced by 2 3 times either way. I don't personally have a preference. I mean, I guess I would say I tend to multiply straight across and just work the big number down. But if you're scared of big numbers and you don't like, and you're not comfortable reducing big numbers, then try the cross canceling just because it sort of breaks it down piece by piece. It is up to you. Cross canceling is not required. It is totally optional. What is required is that the answer be reduced at the end of the day. That's what matters most, okay? So that's multiplication with fractions. You can multiply straight across, or you can cross cancel. Either way, as long as the answer is reduced. It's not too crazy. There's not a lot of steps. Multiplication with fractions, just straight across. You don't need a common denominator. Again, repeat, you do not need a common denominator for multiplying. That will come into play when we do addition and subtraction. What about division, though? What if I have a fraction? We'll do it generically again right off the bat. A over B divided by C over D. Usually people kind of remember how this works because this is sort of odd. You don't actually divide fractions. What you do is you keep the first one, you change it to times, and you flip the second one. People they like to call this keep, change, flip. Keep the first one, change it to multiplication, and flip the second one. It doesn't matter. I mean, keep, change, flip, whatever little cute thing you want to do to memorize it. Bottom line is you keep the first fraction, you change it to times, and then you flip the second fraction. And now we're just back to multiplication again. So A times D would be A over D, and B times C would be B over C. Again, A, D, B, C, just being whatever numbers you want. This is generic mathematic notation. Luckily, like I said, with division, it really just turns into multiplication, so we don't have to spend 1,000 years on this. Let's say I said negative I keep doing that. Let's say I said -5/7 divided by 2/3. Well, like I said, we're going to keep the first one. So that's -5/7. We're going to change it to times, and we're going to flip the second one. And now it's just a brand new problem. -5/7 times 3/2. It's going to multiply straight across. -5 times 3, that's -15. 7 times 2, that's 14. And 15 and 14 don't have anything in common. So right off the bat, we're good to go. Let me go ahead and get one more in here. Because again, it really just is more multiplication. You just have to do a little bit of flipping. One thing I'd warn you about, though, be careful here. Let's say I said -3/4 divided by 8. First thing you probably want to do is make that -3/4 divided by 8/1. Now here's where people will make a mistake. They'll say, well, I can cancel 4 and 8. Remember, cross-canceling is only for multiplication. You don't have multiplication, you have division. So once we flip the second one, you'll see that the 4 and the 8 were not in a position to cross-cancel after all, right? We said any numerator could cancel with any denominator. You can't cancel denominators with each other. This is why you need to wait until it's multiplication. Don't try to cross-cancel when it's still division. -3 times 1 is -3. 4 times 8 is 32. And you just ask yourself, is it reduced? Does anything go into 3 and 32? No, then we're done. All right, so that's division of fractions. Just flip the second one and multiply, nothing crazy. I do want to round this off with one other problem. You guys, you know, and this is pretty normal. You guys seem to have a little bit of a struggle with order of operations, which is, again, pretty normal. So let's do one fraction order of operations problem just to kind of see how that applies. And that should round us off because, again, remember, this homework only has 3 ideas in it, really. Reduction, multiplication, and division. So let's say we got this kind of ugly looking fraction problem. One of y'all emailed me asking why I can't write in straight lines. I don't know. I don't have an answer for you there. It's just always been an issue. I'm sort of a sloppy writer. On a classroom board, it's a little more forgivable, but yeah, here it's pretty open and obvious, isn't it? So we have these two guys in the bracket divided by this fraction over here. What's the order of operations? Remember, first step is grouping, meaning like parentheses, brackets, things like that. Second step, exponents and roots, which we are not dealing with yet, so that shouldn't happen. Third step, multiplication and division. Fourth step, addition and subtraction. And remember, if they're on the same step, like multiplication and division, then you just just give them priority going left to right. So first things first, is there any grouping? Yeah, there's a big bracket here and there's parentheses here. These parentheses here are not grouping because there's nothing to do inside of them. This bracket, however, is grouping, right? It's saying we need to start in there. So first thing we're going to do is go ahead and do these two guys inside here, and because it's parenthesis next to parenthesis, we're going to multiply. Again, the only reason I'm multiplying first instead of dividing first is because it was in the parentheses. So what we really need to work out is 2/7 times 3/8. -2 times 3, that's -6. And 7 times 8 is 56. Could I have reduced this? Yes. The 2 and the 8 could have cross-canceled, or I can do it right now. I'm just going to go ahead and do it right now. Reduced by 2. 2 goes into 6 3 times. 2 goes into 56 28 times. So out of that whole bracket, all of that worked down to -3/28. So what we have now is, in the bracket still, -3/28. And remember, brackets are the same thing as parentheses. They're just there so we don't have to put double parentheses, things like that. So what we have is the following, -3/28 divided by -5/21. We don't need the parentheses anymore. We're just going to go ahead and do the division. So that's -3/28 times, right? Remember, this turns to times, and you flip the second one. So this is it, -3/28 times 21/5. We just need to go ahead and finish this out. This could be some kind of big numbers, right? 5 times 28 is a big number. So let's try to do some reduction. 3 and 28 doesn't reduce. 3 and 5 doesn't reduce. But 21 and 28, something goes into both of those, and it would be 7. 7 goes into 21 3 times. 7 goes into 28 4 times. So what we have now is -3 over 4 times 3 over 5. Nothing big there to reduce, so we just multiply and we get -9 over 20. Okay, so first thing we had to do is multiply these guys, which we did, then reduce, got that fraction, divided it by this fraction, which we kept the first one, changed it to times, flipped the second one, did a little reduction, and we got -9 over 20 as our final answer. I'm realizing I goofed somewhere. Where did I miss? Oh, look at that. See, be careful, y'all. I left my negative off right here. When I flipped this, because we know, how did I know I made a mistake? Negative divided by negative should be positive. So somewhere along the line, I lost something, right? Well, it's right here. We had -5 over 21, and when I flipped it, I did not carry the sign through, so be careful about that. Negative times negative is positive 9 over 21. That should do it for homework 5. Again, remember, homework 5, not homework 4. We're skipping around a little bit. We'll be doing homework 6 and 4 next week. So that's for homework 5. Let me know if you guys have any questions, and I will see you in the next one.